Hello everyone! So I got to go to two great basketball games tonight. The 7th grade B team and the A team, and they both worked really hard, had some great plays. So it was wonderful getting to watch everybody out there on the court tonight. Today, though, we're going to go over categorical data. So categorical data is where we're looking at graphs like dot plots, circle graphs, bar graphs, and just drawing conclusions from the information that we see in graphs. So you guys started to learn these concepts last year, but we're going to dig a little deeper this year. So on our notes, we're going to go ahead and fill in the blanks. So it says categorical data places someone or something, so someone or something goes in your blank, into several groups or categories. For example, favorite color, job titles, names of students, etc. So this basically means that we're just looking at different categories based on what the graph describes. All right, quantitative data measures numerical values. So quantitative means that we're talking about quantities, which means numbers. So age, height, number of siblings, etc. Okay, so the first type of graph that we're going to look at is a dot plot. So a dot plot is a data display in which each data item is shown as a dot above a number line. So this is an example of a dot plot, and you can see here that it has a key. So one person is represented by each dot. So unless you see a key that tells you otherwise, then we would assume that each dot represents one person, and it's showing the new trainees. So it is their time. So this is the new trainees' time. So a lot of them were here at 71 up to here. We only had a couple down here at 61. So we can see gaps in between. So that's where there's intervals where there's not dots. And then clusters are where there's a lot of dots together. So there would be a cluster here in the middle. So when we're looking at dot plots, we look at shape, center, spread, median. So those are all terms that we're going to dig a little deeper into as the week goes on. So let's take a look at this first problem. It says the students in a class were surveyed to find out how many people live in their household. Household members might include parents, step-parents, guardians, siblings, as well as extended families such as grandparents. The results of the survey are shown in the dot plot below. And notice this one specifies that each dot represents one person. So how many students were surveyed? All right, so if each dot represents one person, how do you guys think we'll find out how many people were surveyed? That's right. If each dot's one person, then let's count how many people or how many dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25 students were surveyed. All right, and then it says, what percent of the class has a household of 3 or fewer people? So we're looking for 3 or fewer. So can it be 3 people? Yes. Can it be 4? No, because 4 is more than. We're looking at fewer. So fewer means less than. So we're looking at anything over here to the left of 3 and including 3. So it says what percent? So we know with percent we have to use our percent proportion. We always put 100 here, and it says what percent. So we don't know the percent. Going to put that up top. And then how many students? 1, 2, 3, 4, 5, 6, 7. Part over whole, right? So 7 over, what's our total? So part over whole, our total, right, equals percent over 100. That's what we're using. So our total was the number of students, so over 25. So then we have a proportion. We know what to do from there, right? We set up our cross product. So 25x equals 7 times 100. So 700. Going to divide by 25. Divide by 25. And I know that 25 goes into 100 4 times because I'm thinking about quarters. 4 quarters in a dollar. So 4 times 25 is 100. Well, this is 7 times 100. So basically 7 times the 4 quarters. So 7 times 4 is 28. If you don't know that, you can go ahead and do top in, bottom out. You know that it goes in twice to make 50. You get 20 or 200, and that's 8. All right. So 28% of students live with, it says 3 or fewer, so 2 or 3 people. All right, moving right along. So next, what is a ratio? So guys, a ratio is, we talked about this when we were talking about like rational numbers. We said a rational number can be written as a ratio, meaning a fraction or a decimal. So a ratio is going to be like a fraction, and it may say, let's say, number of boys to students in the class. Sorry. So if we're in a class of 15 and there's 5 boys, we could say 5 boys to 15 students, or 5 to 15, or 5 to 15. And then you can reduce a ratio by finding a common factor. So 5 over 15, well, you can divide them both by 5, and that's the same as 1/3, right? Or 33%, because it's 33 repeating. So that's what a ratio is, and we're going to be using those with categorical data. All right, so next, give this one a try. Colleen's training over the summer for triathlon. The amount of time she spends training daily is displayed on the dot plot. So how many days did she spend training? So if you look at it, it's number of hours for each day. So how many days is how many dots? Good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 days training. Colleen spent 15 days training. And then it says, what is the ratio of days that she spent training 5 or more hours? So 5 or more hours is the first piece of my ratio, 5 or more hours, to the number of days she spent less than 5 hours. So 2 less than 5 hours. So 5 or more hours. So 5 or more includes 5. So I'm going to do everything to the right here. So 1, 2, 3, 4, 5, 6, 7. So 5 or more hours is 7. 2 less than 5 hours. So that's everything that's left. 1, 2, 3, 4, 5, 6, 7, 8. So 7 to 8, or 7 to 8, or 7 to 8. Either way you can write it. All right. Then it says approximately what percent of the days did she spend more than 3 hours training? All right. So what percent? We're looking for a percent proportion. So x over 100. How many days did she spend training? We already figured that out with the number of dots. 15 days training. So what is the percent that she spent more than 3 hours? So 1 hour, 2 hours, 3 hours. More than 3. Does that include 3? No. Right? So we're going to do this little cloud of bubbles. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 15. Now, guys, let's make this easier on ourselves. Can we simplify this ratio? Can we simplify this side of the proportion? 9 and 15 are both divisible by 3. So I can say this is 3 over 5, right? If I divided by 3, divide by 3. So 3 over 5, well, I know what percents are with a denominator of 5. 5 means I'm talking about 20s, right? So 20, 40, 60, 80, 100. So 3 20s is 20, 40, 60. So x is 60%. So we're going to use our sight fractions to help us make this an easier process. Okay, so the next question I want you to think about is what type of data would best be represented in a dot plot? So obviously we haven't talked about things over time. We haven't had percentages on our dots. So it really just represents quantitative data, right? Numbers, numbers of siblings, heights, things that can be put in categories with numbers and represented by dots. So go ahead and contemplate on that. Think about any other dot plots that you've seen. All right, so now we're going to move on to bar graphs. So go ahead and finish up anything you have left on dot plots, and you're going to move on to the bar graph video.